Hi, good morning. It's a great pleasure to be back in live event and to have the opportunity again to speak to an audience, okay, and be away from the remote meetings, okay. Okay, I am Jonet, I am CEO from Voice Interaction, and basically I will be presenting our solution in terms of automatic closed captioning. And I will try to explain exactly the question and the problem in terms of the closed captioning and what is our solution for this kind of problems. Okay. The first thing that we have to understand is the closed captioning is a difficult task. Okay, you have different problems with the speakers, the different accents, the sounds that are interfering, and the fast and diverse content that you have, and also the problem that is difficult to scale manually. Okay, when we are talking about the doing this kind of task manually is difficult to do the scaling when you have different kind of contents and you want to do it not only for something as the live, but also for the offline content. Okay. Basically, for the broadcasters, there is the need to make 24/7. Okay, that means you have to work all around the clock. Okay, and you need to provide a service that should be good, accurate, and always on. Okay. Also, in terms of the content that are online, that means are a huge amount of content that is online, and that you have to provide the closed captioning to give some accessibility in terms of that content. Okay, and is a service that we have to tailor to the different kind of clients and also to the different stations. Okay. One of the things that is relevant is the fact that we need to do some automation. Okay, we need to transfer this task to a full automatic process. Okay, and this creates some challenges. Okay, we need to have a higher level in terms of accuracy. We are talking about something that should be up to 95 to 100%. Okay, and there is also here what we call the word error rate compared with the NER analysis that we do in terms of the system. Okay. Normally, there is no margin for error. Basically, we have to provide as accurate as possible. There is no way that we can have some errors on this. Okay, we have some environment that is changing every day. That means we have new words that are appearing. That means you need to create some kind of features that enable the system to learn and to getting to access to these new words. Normally we have some limited vocabulary. That means the systems are working. That means they have a fixed vocabulary. They are limited. And for example, when we are looking to the English, you have 1.2 million different words. And normally this is not compatible to have a system working on top of this. That means you have to have a vocabulary of 200,000, 250,000 to work on top of that. Okay. And also the kind of programs. One thing is working on news. Okay, that means you have a kind of content that is in some way with a good behavior. Okay, compare when we are talking about entertainment and other kind of programs as sports, where the kind of events are a little bit more aggressive. Okay, and you need to have some way to comply with that. Okay. When we are talking about the technology, that means when we are talking about automatic speech recognition, we see a large improvement in the last years. Okay, and this is basically derived from two different points. One is in terms of CPU. Okay, that means we have faster CPU. Okay, with access to more memory. Okay. And that means the things have been improving a lot, okay? I was just talking with a client and we are discussing latency, and the latency is always depending of the clock of the machine, okay? If you have a good machine with a good clock, that means you can work faster and you have a low latency. Without a good clock, that means it's a little bit more difficult to have a low latency, okay? And that is the point, okay? Besides the fact that we have a large, good CPUs, the fact that we have large amount of data, okay? And this is crucial at these days because basically we are developing algorithms based on neural networks, okay, with different kind of degrees, and these neural networks are able to learn on data, okay? With more data, with good data, okay, we can have better models, and that's it, okay? And basically the fact that we have faster CPUs with more data give us the opportunity to develop new algorithms, to use this data more correctly, with more quality, and at the end we've got a better accuracy, okay? And that's the point, okay? One of the things that is also relevant in terms of this kind of automatic systems are the fact they are speaker independent, okay? That means there is no dependence from the speaker. That means I can have different kind of speakers with different kind of dialects, with different kind of accents, and what the system is to do is to be able to learning that kind of variations, okay? Not only in terms of the speaker, in terms of the audio, but also from creating ways to improve the vocabulary, to increase the vocabulary, and to have better models. That means it's not just a question of having good audio, but also creating good models that are able to respond to this. And for example, from our side, what we do is creating some specific models. That means the idea is not having a model that fits all, okay? Having specific models to sports or to entertainment or to news, and to be able to creating these models and to updating these models with quality, okay? And with all these kind of conditions, okay, is the time to have a full automatic system and running, okay? That means what we can do is creating a full process that is automated. That means we are crawling the web, we are getting the new words, so we can see exactly what kind of new information is available, okay? Just looking to that information, uploading the vocabularies, uploading the models, and creating new models with that information, okay? And this can be do fully automatic. We have to put in place some machine learning algorithms that are able to distinguish what is new, what we can use from that information, and creating the models daily and with this new information, okay? That means also you can, with this kind of automatic systems, bring access in terms, not only in terms of accessibility, but also in terms of contents, okay? The fact that you can have some knowledge from that kind of content because you can do the transcription and you can use that information from the closed captioning together with the timestamps to have access to all this kind of information and make this available to all, okay? That is one of the main points, okay? From what we are talking here is about speech recognition. We know that the speech interface will be everywhere, okay? Not only in terms of accessibility, but also, for example, what we have here in terms of media monitoring, assemblies transcription, the call centers, medical, the spoken content, lectures, in the cars, in house, everyone, every place will see the speech interface, and this will be relevant. And we can see different areas where the speech recognition can have a huge contribution on this, okay? The other point that is relevant is the fact that we are talking about machine learning, AI driven technology, and the fact that we are working on different areas, okay? Not only in terms of acoustic processing, okay? And basically what we are talking here is about looking to the audio, understanding what is the content of the audio, okay? Also in terms of the speakers, okay? That means we have to define when there is a change of speaker, when we have a different speaker turn, when we have speaker clustering, okay, on top of this. Also speaker identification, put the name of the speaker when they is speaking, okay, using these models in terms of doing the speaker identification. And also in terms of event detection, okay? Music, applauses, every kind of event that appears in the audio, you want to do this kind of identification, okay? What we have now is the deep neural networks, okay, that are basically on the base ground of these systems, using in terms of acoustic model, speaker independent confidence measures in order to generate the information that is necessary for the next step, that is the language modeling, the fact that you are creating vocabularies and language models appropriating to specific areas. And the combination of these different processes in the fact that you are modeling the acoustic conditions, the audio, you are modeling the speaker, you are doing the identification and the definition in terms of the acoustic model, in terms of the phonemes for that specific language, and also in terms of the way that you are uploading the vocabulary and creating the conditions to have the best model as possible to that specific task. And the combination of these that are basically AI driven to this. We at Voice Interaction, we have some proprietary technology, and basically this is related with the way that we train the models and how we do develop the system, not only in terms of the training material and training models, but also in terms of the different parts, in terms of the search that we do, in terms of natural language processing, because we have to analyze the kind of output that we are providing and to be in control of that output, okay? Is normally there are some words that normally we have to take out, okay, because it can be offensive, and the system is able, because it's working on top of that words, to be removing that kind of words, okay? Also in terms of the part of software engineering, okay? That means we are talking about the interface that should be intuitive, should be working 24/7, and basically don't creating any kind of problems to the client, and to be reliable and to be always flexible and providing the correct output. What we have from Voice Interaction, what we have the solution for real-time closed captioning, okay, is this solution, the Audimus Media. Basically, in terms of workflow, is for real-time closed captioning, okay, is a solution running or deployed on premises, is running on premises on the client infrastructure, okay, and also we want to be compliant with the CC regulations, okay. This overview, this is a kind of a simple overview of the system. Basically what we do is doing a capture process where we get the access to the inputs. That means we can recording different kind of inputs. Basically if you have SDI, if you have just audio, if you have digital audio, if you have a live streams, okay, that means you can work in whatever kind of inputs that you have. And now what we do is the transcription, okay? We have some, the technology, and basically the premises is to have high accuracy, low latency, and the possibility to have new models with daily vocabulary updates, okay? This is also relevant, and sometimes what we do, and we have been improving this kind, the fact that we have the possibility also to add translation on the process, okay? And for example, here in the West, we have a lot of clients that needs to have the Spanish and the English at the same time, okay? And what we do is, you are working in one language, we translate to the other language in real time, in live, okay? And that means I can provide the two streams of outputs of the closed caching in both of the language, okay? And this is relevant for different kind of markets. In terms of the output, what we do is just integrating to the closed captioning encoder and to provide that kind of information at the end of the system. And what we do, we are delivering the media content with closed captioning to the TV, live streams, whatever. There will be the need for that. Okay, and the idea for our platform is to provide high accuracy, low latency, on-premises system, but also translation, daily vocabulary updates, encoders, and the communication with them, and deliver the media content with closed captioning. Okay, and basically this is also an additional workflow where we look to the SD master to send this information to the encoder. Okay. In terms of offline, we have also another solution, which is Audium Server, and this is basically for integration in workflows when you have a bunch of files and you want to do the transcription of these files and generate the closed captioning associated with these files. And you have one solution for live and another solution for offline when we are working on top of file systems. Okay, and the architecture here is also simple in the fact that we have audio-video inputs, we do the transcription, and we generate a transcription file at the end of the outputs. Okay. Basically, for voice interaction, we have been working for a long time in speech processing technologies. We have been working from the time when we have low data. Now that we have a large amount of data, and that is one of the things that are very relevant for the area, is the fact that we have the ability to provide a good service in terms of the quality of the technology, the quality of the models, but also in terms of quality in terms of the software engineering. Okay. And I think it's ending my presentation. Okay. Thank you. Yeah, on premises. Yeah, basically what we do is we have a process that creating and receiving the information, okay, and we generating a new model, and we upload that model to the client that is running on premises. We can do that kind of definition. Can be something that is very specific to that station, in the sense that there are some names, places that are local to them.
One last question. With respect to different kind of content, like let's say you have baseball and football, is a single machine handle?
Yes, yes. The model should be adequate to that kind of content, but a single machine can work with that.
And that's working on a single presentation?
Yeah, yeah.
Thank you.
Okay, thank you. If you have any questions, we are on the stand here. We can just give you all the answers to that.
Sorry, quick question. Does the manual and AI coexist? Or you have the
Yeah, but the question is trying to put the automatic system to provide you the best output as possible, because if you are doing some kind of manual operation in the middle, it's difficult to do this kind of mixing, okay? Because the speeds are different, okay? Because if you have the system and you have to provide all that kind of information with that specific speed, it's difficult to put some manual process in the middle, okay? But it's something that can be automated to do that, okay? Okay, thank you. Okay.